Chapter 10, Section 3 deals with some of the trigonometric ratios and some of their properties. So let's kind of see what we can find out here. So let's investigate. Sine of 17, type that in your calculator. What does that get you? Should get you 0.29. Sine of 65, 0.91. Cosine 73, 0.29. Cosine 25, 0.91. Okay, so do we think that's a coincidence or perhaps a ratio or an identity? It is indeed a fact, and there is a relationship. Okay, these two gave me the same, and these two gave me the same. If you look at that, that's because their angles are complementary. Good, they add up to 90. So that is our first theorem, the complement theorem. So it says sine of theta will be the same thing as cosine of 90 minus theta. So if they add up to 90, okay, they will have the same value. The Pythagorean identity is close to the Pythagorean theorem. It's going to say cosine of theta squared plus sine of theta squared will equal 1. And then the tangent will be the sine over the cosine. So these are the properties that we are going to work with today. So let's take a look at example 1. Example 1 tells me that the sine of theta is 0.6, and I want to find the cosine and the tangent. Okay, so the idea here, okay, is I want to find the relationship between the two. The relationship is primarily going to be found through the Pythagorean identity. So if you're not sure which one to use, start with a Pythagorean, okay? So the Pythagorean theorem says cosine of theta squared plus sine of theta squared, but we know sine of theta squared equals 0.6. So I'm going to substitute that in, and then equals 1. So I can solve for cosine of theta with algebra. So 0.6 squared is 0.36. So then I would just subtract 0.36 from each side. So I would get cosine of theta squared to equal 0.64. And then if I wanted to get rid of a square, yeah, you got it, we'd square root it. So the cosine of theta will equal 0.8. Okay, just be careful that you don't take the inverse here. It asked for the cosine of theta, okay, which is what I have, is the cosine of theta. Okay, it didn't ask for theta, it said cosine. So make sure you stop there, okay? And then the tangent, okay, well, the tangent told me that it should be sine of theta over cosine of theta. We know the sine was 0.6, and the cosine we just found is 0.8. So if we divide those out, we get 3/4. Okay, so let's try example B. This time it's telling me the cosine is the square root of 5 over 7. So again, if I have to find either one of them, I'm going to use the Pythagorean identity, which says cosine of theta squared. So this time I know that's the square root of 5 over 7 squared plus sine of theta squared equals 1. Okay, so we're still going to use simple algebra here and some of your brain. So if I want to square the square root of 5, you should realize that those cancel, and then square 7, I should get 49. Okay, so you might not want to type that into your calculator, you just might want to use common sense here. So square the top, square the bottom. Okay, so then I'm going to subtract 5 over 49 from each side. So that's going to give me the sine of theta squared. And you're going to want to leave this in a fraction form. Okay, so in your calculator, you can do 1 minus 5/49, turn it back to a fraction. Or if you remember that 1 is the same thing as 49 over 49. 49 minus 5 is 44. So you've got 44 over 49. Okay, either way, you want it to be in a fraction. Okay, so then square root it. So I'll have the sine of theta. Now again, this is not something your calculator is going to do for you. Square root the top and the bottom. Well, I don't know the square root of 44, but I know the square root of 49 is 7. Okay, and you'll know you did it right if the number you started with, okay, square root of 5 over 7, looks similar to yours. Okay, the bottom number should be the same if you do it right. So be careful there, okay, and kind of use some of your common sense. So that's my answer for part A. Part B wants a tangent. Well, I know the tangent is sine over cosine, and the sine we just found is the square root of 44 over 7 over the cosine, which is the square root of 5 over 7. Okay, this is just algebra. So if you remember, when we are dividing fractions, we can multiply by the reciprocal. So keep the top one the same and flip your bottom fraction here. Okay, now again, simple algebra, the 7s should cancel, so we're left with the square root of 44 over the square root of 5. Now, it would be nice if we were done, but we rationalize our denominators. We did this last semester. So you have to multiply the top and the bottom by the square root of 5. Okay, so since they're both square roots, you just multiply 44 times 5 and you get 220. And then the square roots on the bottom cancel, okay, and you get the square root of 220 over 5. Now I know that last semester we would have simplified that, okay, but right now we're not worried about that, okay, so all I need you to do is just leave it and rationalize it. Okay, there are a lot of steps here, so make sure that you're taking good notes about what I'm saying and what you're doing so that you can follow it again later, okay, or ask me more questions at a later time. Okay, and then part C, sine of theta equals square root of 6 over 5, find the tangent. Okay, now this one's kind of tricky because it says find the tangent. Well, I can't find the tangent until I have the sine and the cosine. So it's kind of tricky because you really have to do everything we just did for one question. Okay, so start with a Pythagorean identity. So cosine of theta squared plus sine of theta, so square root of 6 over 5 squared equals 1. Okay, so I know that I've got cosine of theta squared plus square root of 6 squared is 6, 5 squared is 25 equals 1. So I'm going to subtract 6/25 from each side. So I've got cosine of theta squared equals, well, 1 is really 25 over 25 minus 6/25 is 19/25. And then I'm going to square root it. So I'm going to get the cosine of theta to be the square root of 19 over 5. Okay, so I'm square rooting the top and the bottom. Okay, but I don't know the square root of 19, so that one stays. Okay, now I can actually find my question because tan of theta equals sine of theta over cosine of theta. Well, sine of theta is the square root of 6 over 5 over the cosine we just found, square root of 19 over 5. Okay, dividing fractions means I'm going to multiply by the reciprocal here. So I'm going to flip the bottom fraction only. My 5's cancel, and then I multiply straight across. So I get the square root of 6 over the square root of 19. Okay, but then you have to go ahead and multiply the top and the bottom by the square root of 19 because you can't have a square root on the bottom. So on the top, I'm going to multiply 6 by 19, and I'm going to get the square root of 114. On the bottom, the square root of 19 over the square root of 19 cancels to give me 19. Okay, there's a lot here. However, most of it is just algebra, okay, so don't freak yourself out. The hardest part, or the only thing that's new, okay, is this very first step formula. Okay, the rest from there is just algebra. Okay, so relax and just kind of take it from there, okay, one step at a time. Okay, and then D through G are just kind of saying, do you understand the properties? Okay, so if D says cosine of 23 is the same as sine of something, well, that's where we talked about the fact that they added up to 90. So all I would do is 90 minus 23. Okay, so theta here would equal 67 degrees. Okay. Example E says cosine of 42 is sine of 90 minus what? Okay, well, that would just be the 42 from the other side. Okay, so read carefully. Example D actually wanted you to subtract it. Example E says, what are you subtracting? Okay. Example F says tan of 18 is sine of 18 over cosine of 18. Okay, theta in that formula was tan of theta, sine of theta, cosine of theta. It's all the same. So 18, 18, 18. Okay, and example G, I think we're missing squareds here. Typo. Okay, it said sine of theta plus, I'm sorry, it said cosine of theta squared plus sine of theta squared. So thetas are the same, so theta here equals 85. Okay, so when you're dealing with the tangent or the Pythagorean, like E and F, they're the same. When you're going between cosine and sine, it's 90 minus. Okay, so those ones don't try and overthink too much at all. Okay, optical illusion, do you see a woman's face or a saxophone player? Okay, go ahead, write down some questions and we'll go over them tomorrow.